Okay, good day guys. So this is your introduction to limits. So let's start. Limits describe how a function behaves near a point instead of at that point. It is the value that f of x or y gets closer to as x approaches some number. So it's usually written as this form right here, and read as x approaches a, the limit of f of x approaches L. Ang naangdan ko ya, and this is also another good way to say it, the limit of f of x or the function as x approaches a is equal to L. So sometimes if you see this, let me just draw. Okay. So if you see this equation, you can read this as the limit of x plus 3 as x approaches 1 is equal to 4. Okay. Now, limits is one of the gateways to differential calculus, which is the focus of our subject because you will have integral calculus in your second sem. And differential calculus deals with slopes of line. Compared sa integral, para lang makabalo ka mo a little bit, integral calculus deals with area beneath lines or beneath the curves. So, let's have a little background about this. Erase din siya na 9. Okay, so back in the day, with simple algebra, guys, you may have been given certain equations, and then you see this. This is called the slope intercept form or formula, if you will. Now, where y is equal to mx plus b, si m ninyo siya ni ang slope, and of course, si b naton siya ni ang y-intercept. If you're dealing with straight lines, guys, looking for the slope is very simple. It's just rise over run. I think kapila niyo man siya kakabatian. Rise, of course, stands for y, kay siya ni ang rise. Over ang run ninyo, kay siya ni ang run, kumbaga, on the horizontal direction. So, that's y over x. If you plot several points along this line, guys, ang iya sina nga slope palariho na tanan. Palariho na tanan. Okay. However, now that you're in college, and actually most of the things in this world are not necessarily straight lines, you will deal with curves this time. Let me just erase this. So now that you're dealing with curves, it's going to be a little bit different. As you can see here diri, umiyari ko sang isa ka point nga na plot. Kag may isa man ko di ka point nga na plot. Ining blue nyo. Sige, drawing ako pag example. Okay. And then if I draw a straight line tangent to our curve, lain ang iya nga slope. So sa slope diri, m1, slope 1 is not equal to slope 2. Okay. Kag isa pagid ang pinaka-important nga part pagid sa aton nga calculus, looking for maximum and minimum values. As you can see here, nakita sa isa ka point diri sa babaw, which is the highest part of the curve, wherein ang aton nga slope gapahigda, no? Sa aton galing nga tangent line gapahigda. So we can say that the slope is 0. It's quite the same as the one down here, which is the lowest part of the curve. Makasiling kita nga siya na ang minimum. So, yeah, despite being kind of weird, ang slope is important sa calculus naton. So, what do we do to process this? Because as you can see, we have 4 different points and 3 weird slopes, different slopes. So, what happens is, ma-zoom in kita sa isa ka portion sa aton curve. So, ari siya ang aton drawing dire. So, let's zoom in to one part of the curve. This little curve right here. This curve. So, siya niwa. Ay siya. Okay. Bisa na zoom in na siya naton. Curve man sa Japon. So, dapat ma-create kita sa gamay-gamay-gamay nga interval. So, we have talked about this last week. So, let's look for a little interval, guys, of x's and y's para do almost straight line na siya. It will not necessarily be a straight line, but almost there. With that, guys, since we're talking about intervals, instead of a simple y over x, oops, there's a little confusion right here. Let me just change this. Oops, saan siya? Instead of a simple y over x, guys, ang aton nga bag-o nga equation is going to be delta y over delta x. Reminder, especially from physics, delta stands for final minus initial. No? So this means, nakalipat ko, x and the x. Okay. Final minus initial. So this is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So at least even though it's not a straight line, our interval is so tiny. I'll show you later. It's going to be so tiny to the point nga daw straight line na ang itsura sang aton nga curve. Daw lang. May note ko di gani na to. So, yeah guys, ang aton nga point is, or ang aton diri nga na plot is approaching the point but it's not reaching it. So, it's kind of sad. Charot. Okay. So, what are going to be the processes to look for the limits of functions? So, one example, guys, is looking for the limit of x plus 2. And plot the graph, or limit of x plus 2 as x approaches 2. And, of course, you have to plot your graph. Okay. Before we start, there are actually two kinds of limits, no? Let's change your color. Here. If you see your limit looking like this and like this, imagine your number line, no? This is not positive, this is not negative. This just means use values that are higher than 2. So, ari ang aton nga 2, para lang may comparison kita, no? So, ari ang aton nga 2, what are numbers that are higher than 2, pero lapit-lapit sa iya? So, since all those numbers are going to be on the right side of your number line, we call that your right limit. Kag, wala naman sa iban pa, ini siya, tawag ni siya nga left limit. Okay? So, note guys, sa aton nga class, if you see this type of equation wherein wala sang plus or minus, but silingon, pag gusto ka mo sina. So, it's up to you to use the right limit or the left limit. But, if I include, let's start with plus sa aton nga example, subong a. So, if we write there plus, then I am referring to the right limit. Okay? So, what are right limits? Now, think about numbers that are higher than 2. Kag lapit-lapit-lapit gid sa iya. So, siguro ang pinsalan mo mga 2. Siguro man eh. 2.0001. 2.001. 2.01 and 2.1. So, these are good. Maybe you think about 2.5. It is higher than 2 kag lapit siya. Pero, honestly, this is going to change a lot. 2.5 is already far para sa limits. So, limit for me. So, just limit yourself to 2.1. This is already good. Okay? And, after nga makahimo ka na sina, substitute these values to your formula or to your function. So, 2.0001 plus 2, that is 4.0001. This is 4.001. And, right? So, makasiling kita guys nga limit of x plus 2 as x approaches 2 plus is equal to 4. Una bala. Okay. Karoon na tayong plot. Sige, karoon na tayong plot what if limit of x plus 2 as x approaches to negative? Ano ay ang answer? Let's try. So, possibly, madumduman mo 1.9999, 1.999, 1.99, and 1.9. Once you have those values, substitute to your function. 1.9 plus 2, that's 3.9. This is 3.99, 3.999, and 3.9999. And as you can see, 3.9 and all of these other values also approach 4. So in the end, we can say that the limit of x plus 2 as x approaches 2 negative is equal to 4. Okay. Again, mathematically, that's limit of x plus 2 as x approaches 2 from the right side is equal to 4. Limit of x plus 2 as x approaches 2 from the left side is equal to 4. Okay. Now, how do we plot this? This is not exactly the values that we need to plot. Let's go back to your algebra, guys, in yung high school years. And as you know, mag-plot kita, gatag kita values for x. We substitute it again to your function, and then we get a value for y. So, example, x equals 0. So, if x equals 0, y equals 0 plus 2 equals 2, which gives you the point 0, 2. This is 0, this is 2. So our line, or our point, goes here. Now, if x equals 1, then y equals 1 plus 2 is equal to 3. Our second point is 1, 3. So 1, ano si 1 na to, no? 3. Okay. X equals 2. So y equals 2 plus 2, that's 4. So that's 2, 4. So, ano di siya, oh? Okay, wait. Okay. And then if you really want, you can put here something for negative 1. So, if x is equal to negative 1, y is equal to negative 1 plus 2 or 1. So, ano di siya, oh? As you can see, guys, ang aton nga na form, kiwi lang niya ako lagi, ah. Straight. Kiwi. Oh, no. Straight line ni siya. Okay. Straight line ang aton nga na form. And notice, guys, ha, sa 4, ang nasolve natin na limit, ang akon nga line is shaded. Just notice that for now, shaded siya. It's a straight line because the degree of our variable is 1. Again, it's a straight line because the degree of our variable is 1. Once nga ang degree naton masaka x squared, x cubed, and so on and so forth, you will see graphs for parabolas, your hyperbolas, etc. Other curves. Okay? So, yep.